discuss the properties of indifference curve. So indifference curves, those are derived from the axioms of preference and the well-behaved utility function. So it has some properties. So first property is these indifference curves are downward sloping. So if we consider logically, indifference curve shows what is the equation of indifference curve? That u x y equals to constant. So just see that if we are considering a commodity basket in which x equals to 5, y equals to 6. And now if I give one additional unit of x, so what will happen? As per the axiom of non-satiety, the utility level will increase. So if we want to maintain the utility level with given x equals to 6, then why we have to reduce y from 6. So this is that means whenever we are increasing the consumption of x, we have to reduce the consumption of the other commodity y. Now if we want, we can prove it mathematically also. So if we differentiate it totally, we will get del u by del x into dx plus del u by del y into dy equals to 0. So we can write in other words del u by del y into dy equals to del u del x into dx, or in other words dy dx equals to minus del u del x divided by del u del y. So from the properties of well-behaved utility function, we know that del u del x, this is positive, and del u del y, this is also positive. So definitely dy dx, this will be less than 0. The slope of indifference curve is negative. That means it must be downward sloping. So this is the first property of indifference curve. Now the second property is higher indifference curve indicates higher level of satisfaction. And so second is higher IC indicates higher level of satisfaction. So we will prove it with the help of a diagram. So let us consider two indifference curves are there. In horizontal axis we are measuring x, on vertical axis we are measuring y. So this is my initial indifference curve I0 and higher indifference curve I1. So now just we can draw one straight line from the origin. And let's take 2 points. This is G, this is H. So basket G indicates there is OX0 units of x and OY0 units of y. And H indicates there is OX1 units of x and OY1 units of y. So we can write here basket G, OX0, OY0, basket H, OX1, OY1. So definitely we see here OX0 less than OX1, OY0 is less than OY1. So by the axiom of non-satiety, we can say G is preferred to, H is preferred to G. Now we can take another point, H1. So we can write H1 is preferred to H. Sorry, H1 is not preferred, it is indifferent to H. So H1 is indifferent to H and H is preferred to G. So in other words, we can write that H1 is preferred to G. So we can say that any point on this indifference curve will represent higher level of utility compared to G. So next, if we consider another point G1, and let's compare between H1 and G1. So H1 is preferred to G because H1 we have already proved that, and G is indifferent to G1. So by the axiom of transitivity we can write that H1 is preferred to G1. So from here we can conclude that any point on this indifference curve indicates higher level of satisfaction than any point on this indifference curve. So higher indifference curve indicates higher level of satisfaction and lower indifference curve indicates lower level of satisfaction. So if we consider another I dash will represent lower level of satisfaction compared to I0. This is the second property. Third property is that two indifference curves can never intersect. So third property is two ICs can never intersect. So here what we can do, we will prove that if two indifference curves intersect each other, that will create serious logical error. So let's draw two indifference curves. This is A, B, C, D, F. In vertical axis we are measuring Y, in horizontal axis we are measuring X. So if we compare between A and B, A is on the higher indifference curve, so we can write here A is preferred to B. This is one statement. Another is that A and C are on the same indifference curve. So A is indifferent to C, and C and B are on the same indifference curve. So C is indifferent to B. So that implies by the axiom of transitivity A will be indifferent to B. But as per the axiom of completeness, we know that if A is preferred to B, then we cannot say A is indifferent to B. So these two statements, we know that these two events are mutually exclusive. But here we can simultaneously say A is preferred to B and A is indifferent to B. So that violates the axiom of completeness. If we can proceed, we can again find it that D is preferred to F because D is on the higher indifference curve. Next, D is preferred to F and F is indifferent to A. So we can write here by the axiom of transitivity D is preferred to A. Next, B and D are on the same indifference curve. So we can write B is indifferent to D and D is preferred to A. So from here we can conclude that B is preferred to A by the axiom of transitivity. So we know that from the axiom of completeness we know that these three things cannot happen together. These three cannot be true simultaneously. If any one happens, then there is no possibility of others to happen. So here, if two indifference curves intersect each other, that will create serious logical error that will violate the axiom of completeness. So, two indifference curves should not intersect. And the fourth property, indifference curves, they must be convex to the origin. So, we have to prove that as x rises, as we move from left to right of the indifference curve, x rises and y falls. And slope of indifference curve is minus del u by del x divided by del u by del y. So, from the properties of well-behaved utility function, we can say that as x rises, y falls. So, del u del x, this will be falling. And del u del y, this must rise under the condition when x rises, y falls. So, as we move from left to right, forget about the minus sign because it indicates indifference curve is downward sloping. But what about the slope? Gradually the slope decreases. So as x rises, y falls, gradually the slope decreases. So we can see as it moves from left to right, it becomes flatter. So this is convex to the origin. We can prove it mathematically also. So if we start from the slope of indifference curve is given as equals to minus of mu x by mu y. So if we do the second order differentiation, what we will see? That d2y dx2 equals to minus of mu y, and if we solve it by u by b process of differentiation, what we will see? That mu y into d dx of mu x minus mu x into d dx of mu y. So we know that as x rises, marginal utility of x will decline, and x rises, marginal utility of y will rise as per the properties of well-behaved utility function. So what we see? This is negative. So negative multiplied by negative equals to positive, and here minus multiplied by minus this term will be positive. If x rises, marginal utility of y will rise. So the numerator is positive, denominator is positive. So d2y by dx2, which is the curvature is greater than 0. That means this curve is convex to the origin. So these are the properties of indifference curves which are derived from the well-behaved utility function. But we have to remember one thing, that this type of indifference curve, the indifference curve which is convex to the origin, that is derived from the utility function in which two commodities are close substitute of each other, not perfect substitutes, but they are close substitutes. That's why there is the substitutability between two commodities, and here one commodity can be replaced by another. So that's why whenever we are increasing the consumption of x, we are reducing the consumption of Y. But if two commodities are complementary, that means if two commodities are consumed at a fixed proportion, then the indifference curve will be just like U-shaped. So this, L-shaped. This will be the shape of the indifference curve. This is X, this is Y. So let us consider one consumer who consumes tea and sugar. So Y stands for sugar and X stands for tea. So in each cup of tea, he takes 2 teaspoonsful of sugar. So even if his sugar increases, he takes 3 spoons of sugar. That will not increase his utility. So that's why here, keeping Y unchanged, if we increase X, utility will not increase. Similarly, if we take more tea but the amount of sugar is unchanged, we can rise, the amount of sugar rises, but whenever the amount of tea does not change, there will be no change in utility. So this type of indifference curve, L-shaped indifference curve, and all these corner points will belong to a straight line which passes through the origin. So this is the shape of the indifference curve in which two commodities are complementary. So there is no substitutability between two commodities. And if we consider that two commodities are perfect substitutes, then marginal rate of substitution between these two will be 1. So slope will be always equal to -1. So we can find another indifference curve actually which makes 45-degree angle with two axes. So if I can draw it properly, these two angles will be 45-degree each. So this is the case of the indifference curve if two commodities are perfect substitutes. So these two are the extreme two cases. And what is the moderate case? The moderate case is that two commodities are close substitute to each other. For example, we can take the example of pork and beef, Coca-Cola and Pepsi, also tea and coffee. So these are the examples of close substitutes. So in this case, we will have normal shape of indifference curve which are convex to the origin. And one more thing, that one curve, if there are many indifference curves in the same xy plane, then we call it indifference map. So indifference map consists of many indifference curves in the same diagram and higher indifference curve. So if we draw this type of indifference curves, horizontal axis x, vertical axis y, if we consider this indifference curve I0, I1, I2, so we call it an indifference map of the consumer in which higher indifference curve indicates higher level of satisfaction.